You saw that we did day one. Now we're going to do day two. How do you find the inverse of function? We saw that with day one. You switch x and y. How do you tell if an inverse is a function? We're going to use the horizontal line test. But I need to show you that it's not actually in our notes, so I need to kind of demonstrate that at the back. Okay, so it looks like we got 9 problems to do, and we'll step you through it. So first off, how do you find it? Let me zoom in just one little spot maybe. There you go. Okay, how do you find the inverse? Well, first off, we switch the x and the y. So this is y equals 2x squared. And then now we need to undo the order of operations. So that we're going to divide by 2 and then take the square root. So, or no, we got to switch x and y, sorry. So we switch x and y. So x equals 2y squared. And then now we need to solve for y. So we're going to divide by 2 and square root. So we get x divided by 2 root, all under a root, is equal to y. And then we switch it around. So we write the inverse function is root x over 2. And then it says graph, and then we'd make a table to do the demonstration. I showed you the table in 10.1. There's not enough room to demonstrate. We still have our imaginary inverse line right here. That demonstrates it as well. So we'll do that because we got to graph them anyway. So let's start with the first one. We're going to graph y equals 2x squared. So there's my original. Whoops, zoom 6. Zoom 6. Okay, but do you see this restriction right here? This is called a domain restriction. They only want me to graph the part of the parabola that's bigger than 0. So they only want me to graph this part. So you've never seen that before. But that's all that means. Just don't graph the whole thing. Just graph this part. Okay, so it looks like to me, we're going to graph that part. Okay, now we're going to graph the root of x divided by 2. So square root, parentheses, x divided by 2 under the square root. That means close the parentheses and then hit graph. So we have to graph that guy. So it starts at here, 0, and it does one of these. Do you see the mirror image? That means we did it correctly. Okay, moving on. Switch x and y. So y equals negative 2x squared plus 3. Switch x with y, negative 2y squared plus 3. Minus 3 to both sides, negative 2y squared. So now I got to divide by negative 2 and square root. So I get the square root of x minus 3 all over negative 2 is y. And then I switch around and use my inverse notation. So inverse of x, square root x minus 3 over negative 2. So I just rewrote it. Minus 3 divided by negative 2, square root. Remember, you go back up the order of operations. Right? Aunt Sally, multiply or divide, exponents, parentheses. Okay, let's graph. So we have y equals negative 2x squared plus 3. So that's an upside down parabola, but my restrictions my restrictions are only graph this side. X has to be bigger than 0. So we're going to go up to 3, 2, 2, 2. And then we're going to trace that guy right there. Okay. Let's draw our imaginary mirror line. It's just the diagonal. Now we got to graph the root. So you can graph it without it or with it. Square root in parentheses x minus 3. Might need another set of parentheses for this. Or should we rewrite it so that it's easier to type it in? Let's do that. So I'm going to rewrite it as the square root of negative 1/2 x plus 1.5. How did I get that? So 1 divided by negative 2 is negative 1/2. That's in front of the x. I split my fraction. Negative 3 divided by negative 2 is 1.5. So let's type that in. Square root negative 0.5 x plus 1.5. Now I can graph it. And it's that guy. So it looks like I go 3 to the right, and then it tails that way. So we're going to go 1, 2, 3, and then it tails that way. So mirror image. Okay. 3. Replace the f of x with y, so y equals negative x squared plus 5. Switch the x and the y, so x equals negative y squared plus 5. So I see minus 5, and then divide by negative 1. So x minus 5 is equal to negative y squared. Now I'm going to divide by negative 1. Basically, you just send the negative over, so that becomes negative x plus 5, and then change the sign of everything. So negative x plus 5 is equal to y squared. We're going to square root and turn it around. So the inverse function is the square root of negative x plus 5. That's my answer. Okay. Graph. I'm going to put in my imaginary graph. And then let's graph it. So I want to graph negative x squared plus 5. Okay, so that's this guy. Maybe move out of the light a little bit. There we go. But look at my restrictions. X has to be less than 0. So I only want to see this side, the left side. So I'm going to count to 5. 1, 2, 3, 4, 5. And then it looks like it's just to the left of negative 2. So it does one of these guys. And then I'm going to graph the other one. The square root of negative x plus 5. Daisy. Okay. Oh, she went nuts. All right, so there's that guy. And we have it at 5 to the right. 1, 2, 3, 4, 5. And it goes through negative 2. 2 here. And tails off. Had to go get Daisy, my bad. You could have paused it and moved forward. All right, moving on. See what the backside has. Looks like these are the same with no restrictions. So we saw one with restrictions. Let's see one without restrictions. So we'll replace the x with the y. So y equals 5x squared minus 1. Switch the x and the y. 5y squared minus 1. Add 1 to both sides is equal to 5y squared. Divide by 5 and square root. And then turn it around. So the inverse of x is root x plus 1 divided by 5. All right, let's see what the graphs look like. We've got your imaginary line. And then 5x squared minus 1. So no restrictions here. We're going to graph the whole thing. So it looks like I've got a parabola that starts at -1 down here, and then it's kind of skinny. So down here at -1, little skinny parabola there. And now let's graph the inverse. We might want to rewrite it so that it can be a little bit easier. This is going to be root 1/5 x plus 1/5. If you know your decimals, 1/5 is 0.2. So y equals the square root of 0.2x plus 0.2. All under the square root, graph. And we just have the little tail part. So it starts down here. Looks like it's over to the left here and does one of these guys. So what's the mirror image isn't the whole thing, it's just this little part. So without restrictions, you have the whole parabola. Then you have the green part is the root part. Okay? Let's do one more with no restrictions. We're going to switch the x and the y. So -2x squared minus 1. Switch the x and the y. They're gone now, so Daisy will be quiet for us. Maybe. All right. Add 1 to both sides. Divide both sides by -2 and square root. So we're going to square root x plus 1 all divided by -2 is equal to y. So let's turn it around. The inverse of x is root x plus 1 all divided by 2. And that's my final answer. But I might want to clean it up a little bit so that I can type it in my calculator to get my graph. That would be the square root of 1/2 x plus 1/2. Okay. Draw the diagonal. And let's graph the original 2x squared minus 1. 2x squared minus 1 is going to be a parabola down here at -1, and it's a little bit wider of a parabola. than the other one. And the square root is going to be square root of 0.5x plus 0.5, all under the square root. Oh, you probably can't see. And that's going to be this guy. So start there and then tail it right there. So that's what it looks like without restriction. So if I graphed both of them, oops, I missed the negative. So negative 2x squared, negative 2x squared minus 1. So I'll do that one in pencil. So that's this guy. This guy doesn't exist. Okay, so the mirror image is, oh, I didn't divide by negative 2. That's why the mirror image is off. So I got to put a negative there, and a negative there, and a negative there. So let me recalculate my graph. So negative 0.5x minus 0.5. So now my graph's all screwed up. So it just goes this way. My bad on the graph. But now this green guy and this parabola are my right graphs. Okay, but you can see the whole thing isn't a mirror image, it's just a part of it. So that's what you get when you don't have any restrictions. Okay, that looks like we got 3 more. So now it looks like we're going to start with a square root and work our way back to a square. So you replace x with y, so y equals root x plus 4. Then you change the x and the y, so x equals root y plus 4. All right, to get rid of a square root, we got to square both sides. So x squared is equal to y plus 4. Subtract 4 and turn it around. So the inverse function is x squared minus 4. That's my answer. Now we're going to graph. Do a lot of graphs in this lesson. You get pretty good at graphs when you're done. Okay. So we're going to graph the original. That's the square root of x plus 4. That means our graph, we can do this with our calculator. Move 4 to the left. And then, oh, I better get it with a calculator just to make sure. So square root x plus 4. We want it to look good. So it goes through 2, and then it goes off screen, so it does one of these guys. Okay, now we're going to graph the other one, x squared minus 4, x squared minus 4 graph. And that's a parabola. I'll do that one in green. That starts at negative 4. Goes through these two guys, so it does one of these. Okay, so the right side and the blue are mirror images of each other. 2 more. Switch the x and the y, or switch the f of x out with a y. Switch the x and the y, so x equals root 3y minus 9. Square both sides, so x squared is equal to 3y minus 9. Add 9 to both sides, so x squared plus 9 is equal to 3y. Divide both sides by 3, turn it around. So the inverse function is x squared plus 9 all divided by 3. And there's my answer. Okay. We do the graphs to verify. So just use our calculators to get the graphs. So we'll graph the original. So that's the root of 3x minus 9. And that's 3 to the right. So that's that guy. So 1, 2, 3, and then it kind of does one of these. And the other one is y equals. So we got to do a numerator. So parenthesis x squared plus 9, close my parenthesis, all divided by 3. Don't do, without the parentheses, it won't work right. So there's that guy. It starts at 3, and it's a little wide parabola. 1, 2, 3. Okay. And then the right sides where there's no restrictions, so the right sides are the ones that are mirror images. This left side doesn't work because of negatives. Okay. Pause and see if you can do this last one. Okay, we'll replace the f of x with y, 2 root x minus 4. Replace the x and y, x equals 2 root y minus 4. Divide both sides by 2, so x divided by 2 is equal to root y minus 4. Square both sides, square, so that gives me x squared over 2 squared, which is 4, is equal to y minus 4. Now we're going to add 4 to both sides and turn it around. So the inverse of x is x squared divided by 4 plus 4. Just rewriting equations. Okay. Graph it using our imaginary line as a guide to make sure we did it right. Graph the original 2 times x minus 4. So 2 times the square root of x minus 4. So that looks like 4 to the right and kind of a taller tail like that. And the green one is going to be, so you can do however you want. That's 1/4 x squared, or x squared divided by 4 and then plus 1. So we can do that, 0.25 x squared plus 4. And so it goes 1, 2, 3, 4, and then it's a wider parabola. There you go. The right sides are mirror images because there's no restrictions. Okay, so that's how you do inverses. It's a lot of the same problems. There's not much variety, but you'd switch x and y, rewrite it for y, put in the f inverse symbol. Okay, now let's talk about this thing with, is this an inverse or not? So I'm going to flip over and we're just going to do a quick set of notes. All right. So hopefully in Algebra 1, I don't know exactly when you were taught this. I'm assuming you were taught the vertical line test. Okay. So let's do some graphs. So I make an XY graph. I'm going to do 3 of them. Okay. So if I did this graph right here, like a sideways parabola, and then ask you if there were no restrictions, is this a function or not? So this is an Algebra 1 problem. So I'm just reviewing right now. So if I take my pencil and I sweep across, do you touch two parts of the graph at any time? And you can see we do. We touch right there and right there. So then we would write not a function. That means it's not a one-to-one relationship, because there's two ins, or yeah, two outs for every one in. So if x is 1, we would have two different y solutions. So that means it's not a function. Okay. What about this guy, a regular parabola? So if I sweep across, you can see it is a function. So we would write, yes, it's a function. And then the last one, maybe I'll do like a zigzag function. So we'll go like a line like this, and then it zigzags like that. Doesn't matter that it's not a graph you've seen before. We're just asking, is that a function or not? Well, as I'm sweeping across, do I touch at two at the same time or more than one at the same time? You bet. I touch three different times, right here, here, and here. So we would say not a function. It's not one-to-one, okay? But it's got to be the vertical line test. So now, what are we learning new today? Okay, in order to do test to see if an inverse is a function, rather than graphing all the inverses, we just switch the test. It's actually pretty slick. So we're going to do the horizontal line test. Okay. So if I do the horizontal line test, let's do the originals. So I'll graph 3 new parabolas or problems. So let's do a parabola, just a basic parabola. Would its inverse be a function or not? So we're just going to apply, rather than the vertical line test, we're just going to turn our test upside down and do the horizontal test. So does it touch more than once horizontally? It does. So we get to write inverse, not a function. Okay. Let's do a horizontal line test again. We'll do one that is. What about our sideways parabola? Horizontal line test. Nope, it passes. So we get to write inverse is a function. The inverse is a function. And then the last one, let's do the zigzag. Okay. So this one would fail the vertical line test, but we're not asking about the vertical line test, we're doing the horizontal line test. So is the inverse of this a function? And we would say yes, it is. So the inverse is a function. Nice job, guys. Sorry about Daisy.